So in the last video, as promised, I said I was going to do determinants, inverse, and transpose of a matrix. So let's do that.
Took a swing at a wrecking ball and I prayed for my downfall.
So the determinant of a matrix, a 2 by 2 matrix, if you are looking for a determinant for a 3 by 3 or a larger matrix, this is not the video for that. So please try a next video. Now, determinant of a 2 by 2 matrix, a matrix A, B, C, D. The determinant is simply multiplying A times B and subtracting from it B times C. So the determinant is simply this: AD minus BC. That is the determinant of a 2 by 2 matrix. And a determinant is denoted by this. So if my matrix was A, let me do that. If my matrix was A, then the determinant of the matrix would be denoted by A, written like this. So that is my determinant. And that's it for determinant. Simple, right? So let's move on, or let's put some numbers in. I have my matrix A and I have 7, 3, 5, 2. So I'll have for my determinant A, the determinant of my matrix A. So if you see this in a book, it is just asking for the determinant of whatever matrix is inside. So 2 times 7, or 7 times 2, 14 minus 15, negative 1. So the determinant for this would be negative 1. If ever your determinant is 0, alright, let's leave that for now. I want to say it when I'm doing inverse, but if ever your determinant is 0, then your matrix is singular and it has no inverse. Let's do that in inverse. So moving on to inverse. So inverse. The inverse of a matrix is denoted by the name of the matrix raised to a negative 1. And what is the inverse? Well, the inverse of a matrix is 1 over the determinant of the said matrix times. So if the matrix was A equal A, B, C, D, then you negate C and B and you interchange A and D. So you'd have D here minus B minus C and A there. And that is the inverse of a matrix. That's it. There's nothing more to it. So once you can do this, you can find the inverse of a matrix. And these 3 subtopics are tools that we will use to find, say for example, these are what we will use for simultaneous equation. As I was telling you earlier, these are the tools you will use to do simultaneous equations. So let's move on to let me do an example first. Now this is your example. You have a matrix B and the elements of matrix are 2, 4, 6 and 12. Straight away I can see it's 0, but let's do it. So 2 times 12 would give me 24, right? Minus 6 times 4, 24, and I'd have 0. Whenever your determinant is 0, then the matrix is singular. And when your matrix is singular, it has no inverse. But let's show that. So remember that the inverse of B is this: B raised to the negative 1 and 1 over the determinant. In this case, the determinant is 0. Right? And I'm multiplying it now by this, but I will switch my A and D. So 2 will be here, 12 will be there, and I will negate the 4 and the 6. Now if I multiply out these by this, I will have no inverse. I will get zeros, so no inverse. So this is an example of when your matrix is singular, meaning it has no inverse, because 1 over 0 is undefined, so zeros, zeros, zeros. I'm talking too much. So let's move on to a next example where we can actually get a value. Now this is your matrix. C is equal to 1, 2, 3, and 4. you first have to find the determinant. The determinant of C would be equal to 4 minus 3 times 2, 6, will give me negative 2. So my inverse would then be equal to, the inverse of C would now be equal to 1 over the determinant, which is minus 2, times, I switch my 4 and my 1, and I negate these. So when I multiply this out, let me put it up here. When I multiply this out, I have 4 over minus 2 over minus 2, and minus 3 over minus 2, 1 over minus 2. I solve this, I have minus 2, positive 1. Here I have positive, because both are negative, I'd have a positive 1.5, but I will just leave it as 3 over 2, and negative a half. And that is the inverse of this matrix. Moving now to transpose of a matrix. The transpose of a matrix is, let me erase first. So the transpose of a matrix is denoted by, or in some books you will see that you are more likely to see this one, A transpose. So we are working with that. You can see this as well, but we're working with this. So the transpose of a matrix is when you switch rows for columns. So 1, 3, 4, 5, 6, 7, 8, 3, 4. This is my 3 by 3 matrix. So the transpose, this is my A. Let me write A. That is my A. So A transpose now would be equal to me changing my rows to columns. So my first row will become my first column. So I will have 1, 5, and 6. My second row will become my second column. So I'd have 8, 3, 7. For my last one, I have 3, 4, 4. So this would be the transpose of that matrix. And I know I talked about transpose when I was showing, what was that? I was probably showing diagonal or something like that. I was in the types of matrices I was showing. I knew I brought up transpose. Not sure when though, but I brought up transpose. Oh, symmetric matrix. So let's make a symmetric matrix and transpose it for the last example. So a matrix would be symmetric if this happens. So if I transpose this matrix, watch what happens. The transpose of, let me use this one. The transpose of this matrix would be the same. A would be equal to the transpose of the matrix. So it's symmetric. So I'm rewriting this for the column. So I'd have 1, 3, 7. Then I'm changing this for the second row. So I'd have 3, 4, 4. And I'm changing this for this column. So I'd have 7, 4, 5. And that is the transpose of a matrix, and you can see that A is equal to the transpose of the matrix, making it symmetric. Since we are doing symmetric, it won't hurt if we look at asymmetric or skew, because I think my battery was dying, so I had to rush the video with the types. So I have now this matrix A, and remember guys, for it to be skew or asymmetric, the leading diagonal will always be 0. Now remember, for a asymmetric or a skew symmetric, which is the same thing, my transpose will be equal to the negative of whatever is here. So I multiply everything in this by -1. So zeros by -1 would always be 0. If I transpose this, the zeros will be the same, right? So I'd have zeros, 0, 0. They will be the same, and this would be 7 because I'm changing my row to column. This would be -4. My next row to column, I'd have -7 here, right? And the 0 is already there. This +3 will be here, and for the last row, 4 should be here, and my -3 would go here. So we can see that the transpose of this matrix is the negative of this, making it asymmetric or skew. So if you see skew in a book, it is the same thing as asymmetric, meaning that A transpose is equal to the negative of the matrix. So that's it guys for this video. This video was on determinants, inverse, and transpose. And these are the tools you will need for anything you have to do with matrices. Addition, subtraction, and multiplication, those are also tools you will have to use with matrix. When you're doing college algebra, you will probably look at Gaussian elimination. I'm not introducing you to that yet because I'm planning on doing a video about that, but not just yet. I want to do some simpler videos first, and I'm working on a calculus playlist. So
took a swing at a wrecking ball and I prayed for my downfall. And